Well, my clock says it's straight up 12 noon. I'd like to welcome everybody to the Iowa State University Extension Dairy Team Dairy Webinar. We'd ask that you would utilize the chat box to put questions in. And as we are going through our webinar, and at the very end, we will try to get as many questions answered as possible. I don't see Adam on just yet, so we will start today's program with Luiz Ferraretto. He is with nutritionist and extension dairy specialist with University of Wisconsin-Madison, and he'll discuss some of the feeding and harvesting that we do to get quality feed. This all kind of starts with the announcement earlier this year that Corteva, the parent company of Pioneer, announced it is phasing out its BMR corn program by the 2030 growing season. So, as I always say, Luiz, the podium is yours.
Thank you, Fred. Thanks, and thank you all for attending this webinar. So the goal today for us is to discuss how dairy rations will be without BMR, corn silage. But I think what we'll try to discuss with this first part of the presentation here is more like, what are the opportunities that we have out there to keep good quality silage, regardless of using BMR, right? Some of those may be used as a replacement to BMR, but some of the other things we'll be discussing, I think it's, regardless if you use BMR or not, is something to consider and make sure that you keep good silage, have good fiber digestibility, and consequently reach good cow performance related to that. Obviously, because the discussion is focused on potential replacement of BMR, just gonna go through a quick review of BMR, and together with that discuss a little bit about the importance of fiber digestibility. I don't think BMR needs any introduction. It's a hybrid that's out there for many, many years. I think there is a considerable amount of research available. So we do know very well that at the end of the day, BMR does have improved fiber digestibility. But the question that producers and crop consultants and nutritionists have to answer for many, many years is, do those benefits associated with fiber digestibility outweighs the lower yields associated with BMR? And that's a question that I will not try to address. I think it's something that each dairy may have a different perspective on, different needs associated with that. So I think it's quite dependent on each situation, right? But if you allow me to show a little bit of what does BMR bring to the table, this is a 5-year study that we actually conducted in collaboration with Pioneer. And basically we had conventional hybrids and BMR hybrids data coming from across the United States, 4 different regions and 5 different years. So we could try to understand what are the common effects associated with BMR. And I don't think there is anything here that is different to what you are used to see, right? I think we just mentioned the importance of the yields. And I think throughout this exercise, regardless of region, regardless of year, we saw that there's a very consistent effect of BMR hybrids having lower yields than conventional hybrids, right? But the benefits associated with BMR, in my opinion, it's focused on the fiber portion. And if you go to the last 2 rows of this table, you see that something key is NDF digestibility, which in this particular case was 7 percentage units higher for the BMR hybrids compared to conventional, and also the lower UNDF. If you're not familiar with UNDF, it's basically a new metric trying to mimic lignin concentration. And a lot of nutritionists are using that specific metric to formulate diets nowadays. So I think that's a response that's quite consistent, right? Another response that we see here that's not unusual, and actually if you go back to some of the Wisconsin hybrid trials conducted by Joe Lauer over the years, it kind of matches with Dr. Lauer presented several times, is that BMR has a slightly lower starch concentration, right? So I think that if we can quickly summarize the benefits here would be greater fiber digestibility and lower amount of indigestible fiber. And the downsides would be lower yield and slightly lower starch concentration. Obviously, there are other studies discussing about silage hygiene associated with that. Maybe some of the BMR hybrids are more susceptible to some plant diseases and a couple other things. That's out of my expertise, the part of plant health, so I'm not going to touch it. But that's another consideration people had. But why BMR was so important overall from a fiber digestibility perspective throughout the years and continues to be, right? If Corteva will keep that until 2030, I believe that people still will have a lot of opportunities to utilize that well. So the benefit associated with fiber digestibility is that very often when we are able to improve forage fiber digestibility, we should expect some benefits in intake, and because of the benefits in intake, we should see some benefits in milk production. And I think that if we go back 30 years to this review by Oben Allen, that's exactly what we see, right? If you see a 1 percentage unit increase in either in vitro or in situ digestibility, we should be able to have a very good idea on what the cow is going to perform in terms of intake and milk production. More recently, we had this other review from Jung that actually show very similar scenarios when we had a specific scenario of diets containing more than 40% corn silage, which is not an unusual scenario nowadays, right? There are plenty of dairies that will be feeding that. And I think that's quite important because hybrids or strategies that allow us to feed higher corn silage also helps to a certain extent to copy with forage inventory needs, right? But if we compare some of the benefits of feeding BMR to lactating cows, there is quite a high amount of feeding trials that were conducted over the years. I'm only showing here the last 10 years of trials. There are way more trials than that. We actually even had a meta-analysis review 10 years ago with many of those previous studies. And I think the results that we see here match those that we saw during our meta-analysis a while ago. So as I mentioned, a lot of times the benefit of feeding BMR is that you're going to see increased intake, and then together with the increased intake, you're going to see increased milk production. And that's what we are trying to show here. Here, the way the data is presented is cows fed BMR minus cows fed conventional. So basically, we're showing the difference associated with those two treatments, right? And obviously, is quite consistent. But there is more to it, right? When we think about fiber digestibility, it's not just about production. And there are producers that like BMR, not just because of that. Obviously, that being able to produce more milk and making more money is very important. But the cows may also change a little bit their behavior associated with that, right? For some years, we have been presenting this data, which shows a comparison between sorghum and corn is not really BMR, non-BMR. But what we know is when you feed a less digestible diet, the cows will eat less. That's why here you see that intake for cows fed sorghum-based diets is between 88 to 95% of what cows fed corn silage-based diets eat. But those cows also spend between 5 and 20% more time at the feed bunk. And usually this is because those cows are sorting. They are trying to find parts of the diet that will be more digestible, and make sure that they have greater intake and so on. And obviously, this is at the expense of resting time, right? And we know very well that there is a very nice correlation between resting time and milk production, right? Very likely there's a nice correlation with butterfat production as well, because if cows are resting, they are very likely ruminating, and that really makes sure that those cows produce more butterfat. So let's switch gears a little bit and talk about what are the other options out there that we can consider. And one of those options is changing the height of cut for corn silage, right? So if you allow me to use this simple example here, and let's assume for a moment that 8 inches is a common, shop height. I know that there is a lot of variation depending on where you are, depending on the specific setup of your dairy or beef operation, but let's just assume that for a moment, right? So if you increase from 8 inches to 16 or 24 inches, basically what you're doing is something similar to what BMR does, right? You're basically exchanging yield for quality, right? And I think regardless of what we discuss for management practice related to fiber digestibility, that's what the common response is, a trade between yield and quality, right? And I think it's like that for many, many years. This is also true for maturity, for example, right? Although a different extent than what we are discussing here. So basically, if you increase cut height, what you're doing is you are leaving a little bit more of the stock in the field and make sure you dilute some of the more digestible parts of the silage. Okay? So let me exemplify that to you. So this is a study we are actually working on now. I have a visiting PhD student from Brazil that brought some samples. And what Natalia did for this study is she collected the corn plants, separated the leaves and the ear, and then cut the stalk of those different plants for those different cutting heights, right? 0 to 8 inches, 8 to 16, 16 to 25, 25 to 31, 31 to 55, and above 55. And here is what we analyze here in the lab, the MDFD and some of the lignin. And look how does that work, right? If you start with the bottom part here of the plant, you see that that's where there is a higher concentration of lignin. And because of the higher concentration of lignin, we have a slightly lower NDF digestibility in vitro. In this case, we are talking about the 30-hour digestibility. Okay, we also did a couple more measurements like 12, 48, 120 hours. And the results are quite consistent, right? As you go up in the stock, it gets more digestible, okay? And I think that makes a lot of sense. And this is not new data, right? If you go back through literature, there is previous studies, even in the 80s, that show exactly that, right? So that's not something that is new. It's something that people already explore for a good amount of time, and we should explore more and more, right? So if you consider that and you allow a comparison between studies that compare high-low shop, here is a summary we put together a few years ago. And basically, if you compare here silage that on average was harvested at 7 inches compared to silage that on average was harvested at 21 inches, basically the response you should expect is slightly higher in vitro NDF digestibility, slightly higher starch, and obviously lower yield, right? So again, you will be exchanging yield for quality. And I think here we have a clear picture of how, right? I think a downside of shop height compared to BMR is that the increase in NDFD is not as high. A benefit is that instead of slightly reducing starch concentration, you are increasing starch concentration because now you are diluting that same ear that the corn plant has into less material, right? So I do think that there are benefits out there. You also slightly increase dry matter concentration, right? But what do cows tell us about that? And different than BMR, actually, there are way less studies conducted with shop height or cutting height compared to what we just presented to you about BMR versus conventional hybrids. These are 4 studies. The first 3 published in Journal of Dairy Science. The 4th one is a ADSA abstract that is currently under review on JDS. And I will be presenting data from this last study. But basically, the results are a little bit more inconsistent, okay? And you can see that there are 2 studies there that we didn't see benefits by feeding higher shop corn silage to cows. And then there are 2 studies where feeding that was very effective, either in milk production and efficiency or by increasing intake and milk production, right? But interestingly, the 2 studies that where this approach actually worked had greater total tract NDF digestibility. In this case, NDF is not in vitro here. This is the specific apparent total tract digestibility that we collected with feces and markers. Okay. But let me discuss a little bit about this last study that I mentioned. Okay, this is a study that was actually conducted in Brazil. The student that ran this study, Daniel, is currently my PhD student, but he actually brought some samples from this study during the time he was working on his master's for some in vitro analysis. And the reason why they did this study was not to actually test shop height necessarily, okay? The goal was to understand the importance of UNDF in diets. And in Brazil, we actually never had BMR. I don't think, my understanding is that companies were not able to adapt that to Brazil. I may be wrong about that, but that's not the point of the discussion. So because of that, they wanted to test UNDF as it's a new metric that people are currently using, especially those using CNCPS for diet formulation. And shop height was the best option for that. So they actually harvest high-low shop, and the 2 intermediate treatments was basically 2/3, 1/3 ratio of low-high or high-low. And then they created these 4 different treatments with 4 concentrations of UNDF. Okay? So what we have here in this table is how the diet nutrient composition looks like. Obviously, the 11.2% UNDF diet is the low shop height. The 9% UNDF would be the diet where the corn silage was the high shop, right? And you can see the diets were overall similar. Obviously, we had some dilution in terms of starch and NDF. I just mentioned that as you increase shop height, you have a little bit more corn grain diluted into this less amount of plants. So what happens here is they did not fix the diet, right? They just wanted to do that simple comparison. And that's what the diet ended up being, okay? But what did the cows tell us about this specific study? And basically, what the cows show is that as you reduce the indigestible fiber of the diet, you basically increase intake. And by increasing intake, you increase the energy intake of the cow, and consequently, you increase milk production. And this was true for milk or 3.5% fat-corrected milk. Okay? Obviously, we had no differences here in milk fat and protein, and we did not see major differences in MUN either, right? But I think it matches quite well what we would expect from a more digestible diet. And it kind of matches to a certain extent what we saw with previous studies conducted with BMR versus conventional corn silage. A couple other measurements that were performed in that study were related to eating time and rumination. Those effects were minor. We did not see that nice scenario that I tried to describe to you earlier about less digestible diets creating more problems with eating time. However, if we pay attention to diet sorting, we see that, right? And basically, the way we measure diet sorting is we try to compare with a cow consuming a perfect diet, right? No sorting at all, which would mean 100%, okay? So the furthest above 100 means that the cow sorted for that fraction. The furthest below 100 it means that the cow sorted against that fraction. So basically, you can see that for the 11.2% NDF diet, the cow sorted more against large particles in this diet, which happens to be the less digestible particles. Okay, so as you can see, there is some to that theory that I described to you earlier that is going on here. So the cows did eat less and they spend more time sorting, very likely, and produce less milk when fed the less digestible silage. Okay? So something that we are working on and we'll be releasing this summer is a tool so people can try to predict what would be the benefits in nutrient composition and yield associated with changing shop height. Okay, what you're seeing here is the metric version of that, because that's what we prepare first. But we will be updating that with obviously the imperial unit, so you can properly calculate that for acres, tons, and pounds. But basically, the way this is going to work is you will be required to input hopefully your cost of production per acre, because I think this is something important to consider. Then you're going to put here what is your common shop height and where you want to be, or what do you want to try to predict. And then you're going to input the common nutrient composition of your silage. And then based on a review that we just completed, I'm going to present the next slide about that, you can try to predict what happens. And here is what the estimated was, all predicted by the calculator. And then you have what would be the predicted corn silage nutrient composition, the predicted loss in yield, and consequently, the predicted new cost per ton of silage that you would have, okay? I want to make sure that people remember that this will just be predictions, right? It's not going to be 100% accurate. I wish, right? But I think it's something that will help you to try to see, is that worth? Should I consider that for my dairy or my beef operation? And for nutritionists this and crop consultants is something that you can work with your customers and say, hey, maybe this is something we could consider, or maybe for your conditions, I don't advise that, right? So I hope this can be a useful tool, and we'll be releasing sometime this summer. We are just in the process of finalizing, reviewing all the data and make sure everything is accurate for that. But the math behind that is this specific slide here. And this is a review that we actually started many years ago. I probably promised this to a couple of times, if any of you heard me talk about shop height before. But we actually rerun that study. And here is what the predicted effect is for each 10 inches of increased shop height, okay? And I think that it matches what we know very well about how shop height affects corn silage, right? It's going to increase a little bit dry matter. This is new for me because I never paid too much attention to crude protein, but increases a little bit crude protein. It makes sense that corn kernel has more crude protein than the plant. Obviously increases a little bit starch at the expense of NDF, reduces lignin or UNDF, whatever you use as a metric. We are reporting both because there are less studies with UNDF than with lignin in this case, and it will increase NDFD, but all of that change is at the expense of yield, okay? And obviously we are showing the average value here expected, but this will change for each dairy. So my suggestion is, if you decide to implement shop height, perhaps you should test in a couple of fields, right? And see how that works for you, because you want to make sure you have enough forage inventory. Shifting gears again, there's one more thing that I think we would like to discuss about silage quality related to fiber digestibility. And what I want to bring today is silage hygiene. Okay, and this is regardless if you use BMR or not. I think it's something that everybody should consider, okay? But something that we have been discussing more and more is about the importance of microorganisms in silage. In this case, I want to talk about yeasts, okay? This is an old slide, but every year I believe we're going to have a very similar pattern. The yeast load varies drastically based on weather patterns, your management, the year, and so on, okay? But there's a lot of variation out there, and I think it makes a huge difference if you have a very low load of yeasts or if you have a very high, okay? So let me show you what yeast does to the rumen of a cow, okay? So this is a study conducted by Liming Kung in Delaware. And what Dr. Kung did was, and his group did was, they collected high moisture corn samples and they extracted the yeasts from high moisture corn. Then they went back to the lab, they collected rumen fluid of a dairy cow or a couple of dairy cows, and they put rumen fluid into flasks, okay? This is a laboratory experiment, okay? But I think it's quite important to go through that. Then they got a sample, a hay sample, okay, that has none of this yeast, and they incubated that sample in rumen fluid. And then they had some flasks where they did not add any yeast, and flasks where they had low, medium, and high concentrations or high loads of yeasts, okay? Look what happens with NDF digestibility of that sample. That's not the effect of yeast on silage. That effects of yeast in a dairy cow rumen fluid and consequently on fiber digestibility. The more yeast that are there, less digestible it gets, okay? If you allow me to use this 12-hour results to predict the milk per ton associated with that, that's how it looks like, okay? So basically, you see a potential loss in energy value of the silage because of the negative effects in rumen fluid. And let me go beyond that. I actually just completed a study here in the lab. I'm not showing the data today, okay? But we actually did the same thing to corn grain. So we dehydrated corn grain and we incubated with yeasts. And what we saw is lower dry matter disappearance, which means that the starch is less available when you have more yeasts, okay? So I do think we have to start paying more and more attention towards silage hygiene, all the aspects associated with that, right? Starts in the field, continues during ensiling, and then more important than that, what we do during feed out, right? And just to finalize the discussion, here's another study conducted in Wisconsin in Marshfield. And basically, that's what happens to dairy cows when you have a lot of yeast counts, okay? You do decrease milk production. And I believe that part of that is associated with that issue associated with fiber digestibility. Okay. So I do think that there are a couple of things that we have to consider. There are obviously a lot of other topics associated with fiber digestibility we can discuss. I believe Adam will be discussing some of those topics with you. But I just want to make sure I bring a couple of those topics to this discussion. So some conclusions for this part of the presentation is that when you have more digestible fiber in corn silage, you can increase intake, and this allow for the establishment of higher forage diets, okay? Hybrid selection, shop height, and maturity, they do impact fiber digestibility at different extents, okay? But all of them is at the expense of yield. So whenever we talk about fiber quality, it's always at the expense of yield, or most of the time at the expense of yield, okay? I believe the shop height is the best potential option for a one-to-one replacement related to BMR versus other practice, okay? I don't think it works quite the same as BMR, but that's how I see that nowadays. But I also think that silage hygiene affects nutrient digestibility in animal performance, okay? Thanks again for the opportunity to be here today. In case there are questions that I don't have time to answer today, this is my email. Feel free to reach out. Always glad to answer any of those questions. Thank you.
Luiz, thank you very much. And we've accumulated some questions already, and we will hold those till the end of the program. We're going to go ahead and ask Adam to share his screen. And then we'll go ahead. I had mentioned earlier that Dr. Adam Krull is a Pioneer Senior Nutritionist, and he will discuss some of the Pioneer options in the genetic corn lineup. So, as I always say, Adam, the podium is yours.
All right. right. Thanks, Fred. Are you guys seeing my slides?
Yes, we are.
All right. All right. Well, thanks for inviting me to do this. Working through some computer troubles here this morning, so hopefully everything's good to go now. Luiz talked about some really good strategies and things to think about for creating high quality silage, and I'm going to go into a few more details and add a few things to this, and you know, there's going to be ways as we, kind of cycle out of BMR, there's still going to be ways of making milk. We've kind of compared this to when we lost BST years ago. A lot of people thought, how are we going to make milk without BST? And we found out that there were ways of doing that. And I think BMR was a nice tool in our toolbox that we won't have moving forward, but there are a lot of other strategies that we can use to make a high quality silage, and we'll kind of go through all of those. So making high quality corn silage is it's not as simple as just planting it and harvesting it. There's a lot of things that go into making high quality silage. We look at this from the management side of things, the harvest maturity, chop height, like Luiz talked about, the processing and siling, the planting practices. The environment plays a much bigger role than the genetics do. That the environment has 3 times more effect on fiber digestibility than the genetics do. And we've had years where certain weather conditions, and we'll discuss that further, that we've had non-BMRs have a higher digestibility than a BMR planted the previous year in a wetter environment. And so the environment, we got to understand its role in fiber digestibility. And then obviously the genetics will play a role in making quality silage. And I'll kind of, maybe give you a different way of looking at the genetics and how we look at genetics for making a high quality silage. So to make, I'm gonna really talk about the entire planting season and everything that goes on, and all of the areas of opportunity to make better silage. And so we're gonna want to start off right, and these are some things that are under your control. And the agronomics are something that we've learned in the last number of years play a huge role in the quality of silage that we produce at the end of the day. Things as early as tillage, proper tillage practices to make sure the corn plant can put down strong roots, go down and reach those nutrients that are important for growth and to maximize the energy that plant has, and all the nutrients to grow big and strong and put on lots of starch. Planter setup is hugely important. We found that late emerging plants, and this may be just 24 to 48 hours later, when we go back and look at these late emerging plants, they have lower starch levels and lower digestibility than the plants that came out a little bit ahead. And so making sure our ground is ready, our ground is uniform, our planter gives you good seed soil contact, and that can make a huge difference. And then the fertility piece. There's a lot to fertility, and I'm not an agronomist, so we encourage you to work with your local agronomist. But if we short these plants nitrogen late in the season, what that plant is going to do is start cannibalizing the stalk. And when it does that, it's going to create a stalk that's more susceptible to lodging and tipping over, because it's taken a lot of the mass out of that stalk. But it also is going to be lower in digestibility. That plant is saying, I'm going to use all available energy for reproductive, for grain production, and not leave the nutrients in the stalk. And so all of these things play a big role in making sure we're set up for for good results later in the season. So when it comes to hybrid selection, we always say that, we need a good grain hybrid to make a good silage hybrid. If we don't have a silage that can put on a reasonable amount of grain, we can't overcome that lack of energy. The ear is such a big part of a big percentage of the corn silage. We need the ability to put on a big ear and get that energy and get that starch content. But not every grain hybrid makes a good silage hybrid. We need the fodder component to give us the tons per acre. We need that a tall plant. The grain guys, if they could choose the perfect hybrid, would want a short hybrid that put on a big ear so it had less risk for lodging. But for corn silage, we want that big ear, but we also want a big plant with big biomass as well. And when it comes to digestibility, BMR was our step change. That was where we could use from a genetic standpoint, a product that got us a big bump in digestibility. But when it came to BMR, there was pros and cons when it came to BMR. So BMR was very, very successful in certain situations. It improved fiber digestibility, and that was shown over and over. That was fairly predictable to be a step change better than our non-BMRs, and that led to cows producing more. Luiz talked about how the increase in fiber digestibility led to increased milk production, and it also allowed us to put higher inclusion rates of corn silage in our diets, and it had some benefits when used strategically in some of these parts of the lactation that needed that extra energy, the pre-fresh, the post-fresh, transition, high cows. We could get energy in those cows with high digestibility without having to push the starch so high that there were issues with acidosis and other health issues. The challenges of BMR really came to the field side of the equation. From a nutrition standpoint, sure, a nutritionist would love to have BMR, but when we talk to our crop managers, they didn't like planting BMR, and it had agronomic issues. The less lignin content made it more susceptible for lodging. Everybody's seen a field of BMR that's laid over flat. Lignin is actually really important in water transport, and so those BMRs were more susceptible to drought. The genetics were more susceptible to foliar leaf diseases. Consistently lower yields, depending on your geography. This could be 10 to 15%, but there were certain geographies, especially irrigated ground, that the yield drag was closer to 25% on BMR. And that made it just a challenge. And so as these dairies got bigger and land became really valuable, and we had to maximize how much we were getting off the land, that sacrificing in yield became really a tough pill to swallow. And same thing with these large dairies. A lot of them didn't own enough land to put for their own corn silage needs, so they were having to contract acres, and so that led to some challenging conversations on how do we compensate a grower for growing a BMR for us when they're going to get less tons and have more risk for planting it. And so the number of acres of BMR had been going down for a number of years, and so the decision was made by Corteva to phase out the BMR in North America over the next few seasons. So it is what it is, and we'll move forward and we'll make milk without it. So where do we go from here? From a hybrid selection standpoint, we go back to that yield and starch. We need the energy. We need the tonnage per acre. Probably more than we realize. We really need strong agronomic traits. I'll go into some details here about how foliar leaf diseases, a lot of these things that are agronomic related can play such a big difference in the quality of silage we make. So late season plant health, you'll hear me talk about that several times. Late season plant health is where we really need to be focused. Whatever we can do, whether it's the right maturity, the right disease package, the right traits that were put in these products to help us create or to keep that digestibility late season is hugely important. So for maintaining high quality silage, again, I already talked about some of the tillage and planting. I'm going to talk about harvest timing and some of the silage management and inoculants. Strategic harvest practices, the high chopping. I usually present quite a few slides on high chopping and its utility. Luis has done a nice job setting that up, and that's definitely an opportunity for producers to increase digestibility through high chopping. And then to make sure we're kernel processing as well, so we get all the nutrients out of the silage that we planted and harvested. So when we look at selecting a hybrid, the traits I already mentioned these, but we're really putting the basic agronomic traits as number one for creating high quality silage. We have so much data that if we have poor late season plant health, no matter what we did going up to that point, we're going to quickly lose digestibility if our plants are dying and drying, or if they're susceptible to these leaf diseases or tar spot, whatever it is. And so to make a high quality silage, we really need to think about the traits that are really important to kind of have a stable, healthy product going into late season. Dry matter and starch content, we've already hit on that as well. Things we kind of want to not think about too much is starch digestibility. At silage maturity, there's just not a lot of differences at silage maturity. It's an important trait or an important thing we need to know when it comes to feeding animals, but from an actual hybrid selection standpoint, not a lot of difference between those hybrids. And fiber digestibility, this seems counterintuitive. I'm talking about creating a high quality, a high digestible corn silage, and I say digestibility is not a trait I would look for. That's because if you just try to look at the trait of digestibility, there's very little genetic variation outside the BMR lineup. The BMRs gave us that step change, but just from a digestibility standpoint on the genetics, there was such a little difference that it's not really worth choosing specifically for fiber digestibility. I would promote looking at the agronomic traits as your way from a genetic standpoint to ensure good digestibility. So environmental impacts, I already said the environment is 3 times more influential than genetics. So I'm going to talk about how the environment plays a role in fiber digestibility and what we can do from there. The vegetative growing conditions are what really drives fiber digestibility. So, and this is mostly related to water. A dry early season pre-tassel is going to give you a shorter plant, but a plant that it wasn't preparing to grow super tall and laying down a bunch of lignin because it didn't have all of the water there and everything to think about putting on a growing really tall and needing the lignin. So if we have dry early season, we're typically going to have maybe a little less yield, but we're going to have a higher digestible plant if we have that. If we got really wet pre-tassel growing conditions, that plant has everything to grow, and it says I'm going to grow tall and big, and it's going to lay down lignin to support a big tall corn plant. So wet early season is what's going to lower your digestibility. In that same stance, irrigated corn silage is almost always going to be lower in digestibility because we rarely turn off the water when we are irrigating for corn silage. post tassel, that's what really affects your grain yield. And so if we can have the perfect corn silage scenario would be, a little bit of a drier early season, so we have good fiber digestibility, and then the rain comes on post tassel, we get that added starch, and then the rain shuts off at harvest, so we can get it harvested at the exact right time. And so again, some of this is under our control, but a lot of making good silage is the result of what environment it was grown in. So plant health, we already mentioned, late season plant health. A healthy plant is going to maintain fiber digestibility better. And I think that's a concept we need to think about a lot. Luiz talked about, the yeast having an impact and dropping digestibility. A lot of the things I'm going to talk about are when we have good digestible silage coming out of the field, we want to do everything we can to maintain it. Or we have good silage going into the harvest season and we want to get it harvested at the right time. So good healthy plant is going to hold that digestibility better. It's going to give us more starch, more biomass, good healthy leaves that can have more photosynthesis. They're going to drive starch. They're going to drive biomass so we can get more yield, more starch. And it gives us a wider, more flexible harvest season. And this gets really important to make quality silage. We got to get it harvested at the right time. If we have poor late season plant health where the plants are dying and drying, we got to get out there quickly. We might have a week where it's in that ideal time frame, but if we have really, really good late season plant health and that plant is still green and healthy, we may have 10 days or 2 weeks. We may have almost twice as much time to get that silage harvested and still have a quality product. So again, this is influenced by hybrids and their resistance to late season stresses. Some of the traits that are in the corn, fungicide use. I'll talk a little bit of that, and I already mentioned fertility plays a role here, making sure we got enough nutrients late season. So late season plant health can drop very rapidly. We've looked at some of these plants that are similar plots that have some plant health issues, and here's some healthy and some disease stalks. When field B, when its late season stressor came in, it dropped 13 points in fiber digestibility in 9 days. And whereas the stalks, the healthy field right next to it, was less than 1 point of a drop. And so, again, this late season plant health, trying to keep that good digestibility is really, really important and can change very quickly. Whoops. So we'll talk about fungicide use and how it can be used. There's certain geographies that always use fungicide, certain geographies that never use fungicide, and some kind of in between depending on their disease pressures. I like this slide because you can visually see the difference in the silage where we use fungicide in a controlled trial here. We got really nice green corn silage. Our control, which had heavy disease pressure, is already very brown at harvest. So we can visually see the differences in fungicide use. The next couple slides are some low pressure and high pressure disease environments and what the use of fungicide does for some of our yield metrics. And so the top 2 bars here are our fungicide use in a low pressure environment throughout the harvest window. And we still saw, even in low pressure, a 3 ton per acre increase in yield by using a fungicide. And in the high pressure, high disease pressure field, we had almost 4 tons per acre increase in yield with the use of fungicide. When it comes to grain, we had about a 20 bushel per acre bump in low pressure environments and almost 40 to 50 bushel per acre equivalent of difference for the use of fungicide in a high disease pressure environment. So it's going to have dramatic increases in the quality of your silage by having that much more starch accumulation. When it comes to fiber digestibility, we didn't see as much differences until we got to the high disease pressure environment. And in the heavy disease pressure where we didn't use fungicide, we really had significantly lower digestibility, and it was dropping very quickly throughout that harvest window. So if we have a healthy plant and we can leave that plant out there a little bit longer because it is healthy, we don't have to go harvest a plant that's dying and drying. For every 1 point we get in silage dry matter, so this is waiting a little bit longer, letting the silage get a little bit drier, we can gain a 0.6 of a unit of starch. That's 5 bushel per acre equivalent, a third of a ton in dry matter, and with a minimal, just 0.2% decrease in fiber digestibility. So if we're able to keep that plant out there an extra, instead of taking it at 32%, we take it at 37%. That's 25 bushel per acre grain equivalent. A ton and a half more silage, 3% higher starch percentage in your silage, with really only losing a point in digestibility. Now again, the disclaimer here is in healthy corn. If we have diseased corn, poor late season plant health, this can drop very quickly. But if we have good, healthy corn late season, we can get all these benefits with very little drop in digestibility. All right, so finishing, this is where we can have some control over what's going on again. The things that drive yield, harvest timing is the most important thing that drives your total yield. Hybrid, planting date, plant density all play a role, but we'll talk about harvest timing here next and how that's important. And so within Corteva, we have a tool, a silage harvest predictor, and essentially it's looking at all of your fields and saying, when is it going to reach 3/4 milk line? 3/4 milk line should be, in a healthy plant, our target for harvest. We're not really as concerned about whole plant dry matter and cutting stalks, drying them down, figuring out whole plant dry matter. Our goal is to leave that plant out there as long as we can, as long as it's healthy. And so our goal would be to get to 3/4 milk line and let the kernel moisture dropping be what drives the lower moisture of the entire silage plant, and not the leaves and the stalk being what's drying down the whole plant. And so we have a product we can put in your field, your plant date. It'll track GDUs. It'll use the 14-day forecast to predict the next 14 days of GDU accumulation. And what you get is a summary that looks like this. It's essentially for every field you put in, it gives a estimated harvest date, and just allows you to plan your harvest to try to get your field harvested at just the exact right time. And this can be really helpful for not only making high quality, but if you have if you're going to make some earlage or high moisture grain, or you're going to leave some for dry grain, you can look at where are your bottlenecks. If I'm going to have a lot of corn ready early, a lot of corn ready late, which fields can I switch and designate for other areas, or we just get a plan for harvest. We're going to start on this field, and then we're going to go to this field, and then we're going to go to here based on all of the predictions. There is a little bit of ground truthing here to get the exact start date perfect, but the order in which they're ready is really, really accurate. You may need to adjust 2 or 3 days one way or the other based on local growing environments, but it can be a very powerful tool to maximize getting that silage harvested at the appropriate maturity. So I'm going to go into a little bit, just a couple slides here on silage inoculants. Again, like Luiz said, we need to keep silage as good as we can and not let spoilage organisms lower silage. Other than starch digestibility going up over time, silage can only get worse. over time, if we've got spoilage, if we've got aerobic conditions, we're going to have silage that gets worse and worse over time if we're not doing a good job protecting it. And so every silage inoculant will do one thing. It will stimulate rapid fermentation, and the quicker we can get it fermented, the less losses we'll have, the more sugars will be retained, so the higher quality of silage we'll have. The next level of inoculants are the inoculants that contain a Buchneri strain, and those those are really inhibitory towards yeast production at feed out. And again, these yeast, Luiz talked about it, these yeast, as they start using the sugars and creating heat and breaking down the silage, they're going to lower the quality of that silage. So using a Buchneri to prevent heating, to prevent that yeast growth at feed out, can really help maintain the quality of the silage. And then we do have the potential, a Pioneer does have an inoculant that will increase fiber digestibility over time. This is a unique and patented strain that is exclusive to Pioneer and can be used to increase fiber digestibility in the bunker while it's before you feed. And essentially, the strain that's in here it's a Buchneri strain, and it produces an enzyme that breaks down that linkage between lignin and cellulose and hemicellulose and increases the rate at which silage is digested in the rumen. And so you get all of the benefits of a regular inoculant and a Buchneri inoculant, but you also get the added digestibility of the silage. So we can get the improved dry matter intake, improved NDFD digestibility, improved gain per ton of silage, improved feed efficiency, reduced heating, reduced dry matter losses, and this works across all levels of silage, whether it's low, fiber digestibility originally or really high digestible. It still is improving digestibility from where it was. The way we've seen a lot of producers use this product, the 11 CFT product, is if we know we have growing conditions that are wet early season and we think our corn silage is going to be poorly digestible that year, that's a place where we need to put in a silage inoculant that can help us increase that digestibility, so we don't have to manage an entire year around a really low digestible corn silage. So my final kind of take-home points for improving silage quality, the agronomic practices, don't overlook those, especially early season at planting time. Choose the right hybrid for your field, and work with your seed salesman to get the right hybrid for the right field. Everything we can do to maintain late season plant health, and hold that fiber digestibility as high as we can. Harvest at the appropriate time to ensure that quality. Use some of these strategic harvest practices. So this is, high chopping, is definitely a tool in our toolbox. Make sure our length of cut is appropriate. Make sure our kernel processing is where it needs to be, and then protect it. We've made a good quality product. Let's use a silage inoculant to hold that digestibility as high as we can to ensure a quality product to be fed. And that is all I have, and I'll take some questions.
Thank you very much, Adam and Luiz. We appreciate the information today. What I'd like to do is just take a minute while we're getting questions into the chat. Jen Bentley's going to help me present those, but remind everybody that these programs are recorded. It takes us 5-6 days or a week to get them on our website there with the Iowa State University Dairy Team. And you will also be receiving a announcement when that is going to be ready, as well as a link for a survey. Let us know. It's only 4 questions. Help us kind of do some planning for the next one. So I know we've got some questions that came in. Jen, do you want to kick them off?
Sure can. So it looks like we had some questions that came in early on when Luis was presenting, but I think both of you addressed the high chopping questions. And so both of you can answer this, but when high chopping at 8 to 16 inches, considering yield loss, is that % of yield drag comparable to BMR versus conventional products yield difference? And if so, you give up yield planting BMR, so why not give up yield to high chop, sorry.
Oh, I agree. I think that if you had the experience of handling a lower forage inventory because of having BMR versus conventional, I think you can copy with the changes in high chop, right? I actually think that the benefit of high chop is slightly lower than BMR, but I think the yield drag is also a little bit lower, especially because you would be using a conventional hybrid. I think Adam gave a snapshot of some of the benefits associated with the plant health for the conventional hybrids, that maybe some of the BMR traits were not as good. So I do think that, yes, that's certainly an opportunity. So.
And then there was another question about just some producer perspectives of, they've heard one farm going back through and chopping remaining stubble after high chopping to blend into a heifer ration. Is that common among people who have adapted to chopping high?
I don't know if that's common. I'll let Adam chime in, but what I want to mention about that is some years ago here at UW, people were testing harvesting corn silage immediately below the ear. They call that topplage, and then it would require coming back and get the stalks and having an extra silage related to that. I don't think that became popular because my understanding is that going twice through the field, it's quite expensive. So because of that, I don't see a lot of benefit. So I'm assuming a farm doing that to generate more heifer feed will be primarily associated with a need for forage inventory rather than a common practice. But I don't really know the answer about being common or not. So
Yeah, we do hear about it occasionally. I would say the expense of it for the quality of feed produced is typically a negative incentive. And another thing to always think about is your nutrient losses. There's a lot of nutrients still in that fodder for the next growing season. So what we're removing there, you figure that into your equation as well to the quality of feed that you get. That's why it's not super common. It's something definitely that could be done if you just need tonnage, you need some heifer feed. But I think it's worth an economic analysis and see if it's worth it for everybody's scenario.
And then another question that came in is high chopped corn more hygienic?
So we tried to test that with our meta-analysis, and we were unable to find enough studies that actually go through fermentation, microbial counts, and things like that. But a significant response that we found is lower ash content, okay? And I think that's related to soil contamination, not the true ash content of the different parts of the plant. So if you allow me to assume that, yes, it's supposed to be better because you are bringing less soil and consequently less microorganisms. But I don't think we have enough research to showcase that, although I think it's just common sense from that perspective. So.
Go ahead, Fred.
I was just saying, we had a question come in from Scott asking what role does plant population seeding rates have on the NDF or the UNDF. Heard that it's reduced seeding rates have the potential to increase silage quality. And I guess this is for either one of our presenters.
Yeah, I can hit on this. It's a slide I usually show, but I left out for time's sake today. Um, there is a correlation between plant population and digestibility, but the difference is fairly small. You have to really move the populations a lot to get a little bit higher digestibility. And so, you might have to go from a 36,000 to a 26,000 population to see a difference in digestibility there. And the problem is when you do that, you significantly lose tonnage. And so we don't see people doing this when from a cost, again, it's that economic piece on a per acre basis. The amount that you would have to drop populations to move the needle on digestibility to the low side, you're going to give up way more tons and cost yourself on a per acre basis. So maybe you've got a different opinion, Luiz, but that's the data we've seen.
No, I think it matches what literature shows. It's we run a series of studies, 3 or 4 studies with that, and we actually didn't see any change within normal seeding rates. So I think it matches exactly what you are describing. It's probably a good way of increasing yield, but not necessarily a great way of improving the quality itself. We also tested earlage during that time to see if it would change something in the years, and consequently earlage or high moisture corn quality, and we also didn't see much. So.
And then there was a question about, have you heard anything about growing short statured corn for corn silage? There's been some claims that it will be very high in digestibility and somewhat similar in silage yield.
Yeah, we can't say too much yet, but yes, stay tuned. Yeah, I would say the initial thought was short corn wouldn't work for corn silage. Some of the initial data is suggesting it could be very beneficial for corn silage from a yield and quality standpoint, but that is still being evaluated.
Yeah, from my perspective, I think that there is some research going on that I'm part of in Europe. Obviously, it's a different case scenario, but the initial observations that we have, I don't have yield data at all, but some of my collaborations in Italy do suggest some good nutritive value. I don't know if it's as good as BMR. There is one study published comparing short corn versus conventional versus BMR. But here's where my bias is, and I apologize for that, but this is a pure company trial. So I will take with a grain of salt that. I'm not saying it's not like that. I'm just saying I want to see some university data replicating that before saying that this is the case. So
Jim pointed out that if you're a fan of BMR, Kingfisher still will be marketing a BMR hybrid. It's conventional only. Can you kind of help give us the information on that, Adam?
As far as what Kingfisher has?
Yeah, tell us what that hybrid is.
So that would be a different company that's not under the Corteva umbrella. And so that would be, again, a conventional non-GMO type product. I don't necessarily have any experience with people planting it to see how it compares to what was out there within the Corteva lineup at the moment.
Started out saying it's conventional, it doesn't have the stack traits. Will there be other companies who have conventional BMR hybrids out there?
I think there's the potential. Corteva does not have any plans to sell our genetics to any other companies. But BMR is a trait that you can find genetics that exist in the environment and so there's nothing stopping another company from picking up a conventional BMR and selling it as well.
Jen or Jim, what are you seeing for questions out there? Anything coming in?
I'm not seeing any additional questions, Fred.
There was a question or some discussion going on about FOD. I don't know if Bill Mahana has any experience, FODD, that processor that separates the starch from the fodder. Does anybody have any experience with that? There seems to be a lot of interest in it, but I'm not familiar with systems, any farms that have that system.
I don't have experience testing that, Jim, but I think it's an interesting concept because it matches a lot of the research we have related to particle size. So similar to what we discussed about fiber digestibility and effects on feeding behavior and sorting, diets with coarser particles do tend to cause exactly the same issue, if not worse, than when we have lower fiber digestibility. So from that perspective, I think it would be interesting to see something like the FOD approach, because you basically can eliminate some of the very coarse particles and shift that towards maybe your transition cows or heifers or a different purpose, and feed some of the smaller particles. But I'm unaware of studies, and I don't have a field experience with that either. But I really like the concept idea of that. So.
Not seeing any more questions. Any final comments, Adam, that you want to put into the record?
No, I mean, we'll continue to have BMR, you know, until no later than 2030. So, you know, it gives everybody time to think about, you know, transitioning away from it, and give everybody time to, you know, think about all these other things to keep quality.
Thank you. Luiz?
Yeah, I think there are a lot of opportunities out there, and I think people have to make the best they can with their corn silage, and I'm sure those that plant BMR will figure out different ways of moving forward with that. So, and if you need any help, any discussion, always feel free to reach out to us. So.
Thank you very much, and remind people if they want to go back and listen to parts of this again, give us about a week and we'll have it up on the Iowa State University Dairy Team website. And we'll also send out a reminder that there will be a survey available to share what you heard today. Again, thank everybody for attending. Thank our two presenters, a lot of great information. Jen, thank you for helping me out today.
Sounds good. Have a good day.
This will conclude the program.